In our past videos, we've been writing rules for general sequences and series. In this video, we'll get a little more formal about how we write and talk about those rules, specifically for arithmetic sequences and series. We'll also use those rules that we write to find the missing terms of arithmetic sequences. So here we can see the general form for an arithmetic sequence. This rule lets us find the nth term of an arithmetic sequence as long as we can fill in the first term and the common difference. And I already kind of defined these for you, but there's what each of those pieces in the formula means. A sub n is the nth term, a sub 1 is the first term, and d is the common difference in the arithmetic sequence. So let's jump into an example here. Find the 11th term of the arithmetic sequence that goes 3, 9, 15, 21. Well, we have to fill in a sub 1. We also have to fill in d, the common difference. We can right away tell that a sub 1 is just 3. It's our first term. We can also tell relatively easily in this case, to go from 3 to 9, we need to do plus 6. Now, they already told us this is an arithmetic sequence, so we don't have to confirm that it's plus 6 every time, but it is. We could check that. So now we go ahead and we fill in the blanks. A sub n is equal to a sub 1 is 3 plus, we have to fill in the common difference. The common difference is 6 times n minus 1. Now to find the 11th term, to find a sub 11, we just fill in that one last missing variable, which is n. So we're going to fill in 11. And then from there we go ahead and we do some relatively simple arithmetic. 11 minus 1 is 10. So I have 3 plus 6 times 10. And then 6 times 10 is 60, plus 3 is 63. And there's your final answer for your 11th term. Another example. Find the 14th term of the arithmetic sequence 11, 7, 3, negative 1. So again, we have our a sub 1, 11. And in this case, again, we can tell relatively easily our common difference is negative 4, because we go down 4. So we can fill in the blanks in our formula. A sub 1 is 11, and then we're doing minus 4 as our common difference this time, times n minus 1. And we're looking for the 14th term, so to find a sub 14, we're going to just plug in 14 for n. And again, with some relatively simple arithmetic, we can finish this problem off. This is 4 times 13. 4 times 13 is 52. 11 minus 52 is negative 41. A couple more examples with a different setup here. So in this case, we want to find several missing terms that are between two terms we already know. So in this first example, we know that the first term is 9, and we also know that the 5th term is 25. So again, we can go ahead and fill in the pieces of our formula that we know. For example, we know that a sub n this time is 25, right? Or specifically a sub 5. We also know that our first term is 9, and then plus, what we don't know is the common difference d. But we already are working with the 5th term, so we can plug in 5 for n minus 1, and then solve this equation from here to get our common difference. So we can subtract the 9 over. 25 minus 9 is 16 equals, and then 5 minus 1 is 4, so this becomes d times 4. Well, to finish solving, we're just going to divide both sides by 4, and we will get that d equals 4. Now, to find all these missing question marks here, we could go through and use our formula to find a sub 2, then a sub 3, then a sub 4, or we could just say, well, to get from 9 to the next term, I know I have to add 4. So I would go 9, then 13, 17, 21, and then there's our 25 that we already knew at the beginning. In this second example, we're going to do the same thing, just with some different numbers. So again, we know a sub 1 and we know a sub 5, so we can fill in the blanks. Negative 7 is going to be our a sub 5. A sub 1 is 5. Plus, we don't know the common difference, and we're going to plug in 5 and 1, because those were our terms we're using. Subtract 5 over, we get negative 12, equals 5 minus 1 is 4 again, so d times 4. Divide both sides by 4, and you get that d is equal to negative 3. So again, we can use that to fill in the rest of the pieces. 5 and then minus 3 will give us 2. Minus 3 will give us negative 1. Minus 3 will give us negative 4. Minus 3, we've got our negative 7 that we already know should be there because it was given.